The videos in this series are about Spark. They were created in December 2015 as a project in our File Organization and Database Management course in the Masters of Data Science program at SMU. All data was current as of that time. We will begin with an overview on Spark itself and how it fits into the world of big data. After that, we will show you how to get Spark up and running on a VM on your own system. And finally, we will demonstrate how to run your first Spark job using Python. Let's get started. Our Spark overview will cover why you should care about Spark, what it is, why there's so much interest, how it relates to Hadoop, and how it performs. So, why should we care about Spark? Well, there are really two key things to remember. First, Spark is going to run analytics faster on big data. And that's because the complex workflows that are typically present in an analytics use case normally have iterative tasks in play. What Spark enables in comparison to MapReduce is the ability to utilize and pass data that is cached in memory, making it much faster. Additionally, it allows the users to be much more productive in their day-to-day task. Users can build their predictive models faster, which allows them to iterate more rapidly. And because they can build multiple models concurrently without having to wait for the system, it allows them to conduct more experiments over a shorter period of time, thereby enabling them to come to solutions to their analytic use cases faster than ever before. So what is Apache Spark? Well, by way of background, Spark was developed about 6 years ago at the AMP Lab at UC Berkeley. The founders are the people who incorporated Databricks, which offers a cloud offering of Spark and commercial support for it. The technology for it was open sourced about a year later in 2010, and it became a top-level Apache project very recently in 2014. Since 2009, Spark has had more than 800 developers from over 200 companies contribute to this project. This is another advantage of Spark, as the open source world allows for many people with varying degrees of skill and knowledge to contribute and improve the technology. There are multiple libraries that are included in Spark that allow for programmers to use the same abstraction layer. This also makes it much more efficient because they are reusing code, reusing skills, and really the goal of this technology was to generalize the old MapReduce model so that new applications can be supported within the same engine. As you see in the diagram here, fundamentally, the Spark Core API allows for programmers to interact with it via different programming languages, such as R, Python, Scala, Java, and so on. And on top of that API is a set of libraries that provide different kinds of capabilities. SQL, the streaming technologies, Spark, MLab, which is the machine learning library, as well as graph computation with GraphX. So what this provides is a very broad set of capabilities that allow organizations to extend on top of them. Let's talk a little more about why Spark is generating so much interest in the world. Probably the biggest reason is that it outperforms older solutions and it scales horizontally. Part of the reason that it's able to do this is because of a notion called Resilient Distributed Data Sets, or RDD. You can think of this as a way for Spark to cache data in memory across the cluster, which allows for chained operations or any kind of iterative operation to very quickly operate on the data without having to incur the overhead of reading and writing the data to and from disk. This makes it much more efficient and perform more rapidly than the old MapReduce model. Furthermore, because it abstracts this core for the programmers, it provides a much easier environment for them to program to. There is a very simple and intuitive API that a programmer can interact with, and they can use their favorite language to do so. And as I pointed out before, there are several common programming languages, including Python, which is what we've been using, that they can leverage for programming and utilizing Spark. It integrates very well with existing big data infrastructures. In particular, it integrates very well with Hadoop and the Hadoop distributed file system. It also provides support for various other services, including things like Kafka, which is an internet-scale messaging mechanism. It is an open source big data predictive analytics infrastructure, and there are many organizations that are contributing to it in building out these libraries of big data predictive analytics. Many of them, in fact most of them, are specialized for conducting analytics over very deep and very wide data that is typically what you find in the Hadoop infrastructure. Therefore, Spark is very popular and holds a lot of benefits for people who are conducting analytics in those kinds of environments. It's important to understand the relationship between Spark and Hadoop, as there is a lot of misunderstanding here. First and foremost, Spark is not a competitor to Hadoop. Furthermore, Spark does not even require Hadoop. Now, there are different degrees of relationship between Spark and Hadoop, though. On the one hand, they are very complementary with one another, and Spark by itself does not have a native storage system, and therefore it integrates very well with Hadoop and the Hadoop HDFS storage system. Spark is a great combination with Hadoop HDFS, but it can also be utilized with data that's not stored in HDFS, using other kinds of storage mechanisms. So from this perspective, there is great synergy with Spark. Spark also offers alternatives to things that are available in Hadoop. For example, Spark is able to use Yarn to run on the same nodes in Hadoop as the data that's being analyzed. So it can use Yarn as a resource manager. By doing this, it allows the administrator to control how much resources Spark users will get versus the other workloads that are running in their Hadoop environment. So it provides this easy and discrete environment to manage a workload. However, there are also other infrastructures that Spark can run other than Yarn. Now, there is one area that Spark does compete directly with Hadoop, and that is in the area of Spark versus MapReduce. Spark is a competing technology to Hadoop MapReduce, and it is an either-or selection. Now, it's important to also have a level set with respect to Spark performance. Anyone who's been paying attention has heard a lot of great claims about Spark performance, and in particular that Spark is 100 times faster than MapReduce. And this is true under very specialized conditions, under a very specialized test case. It's important to relate performance back to the real world, though, and what are data scientists going to be doing in their organizations, and what can they expect to see? Now, the reality is that when you're running a complex workload with a data file in memory, you can expect from a 10 to 15 time improvement using Spark over MapReduce. And the factors that are going to influence this performance are pretty straightforward. First, if you have a complex workload where you're going to be iterating over the same set of data multiple times, Spark is going to be faster because the data is held in memory and the data in these operations occur without having to read and write the data from storage. Similarly, if there are several operations that are chained together into a single job, this is going to be faster because it's going to avoid the job steps of reading and writing to storage in between each of them. So this ability to pass data in memory from one step to another is a significant part of what speeds up the operation. When we have a complex workload where the data does not fit into memory, we should see about a 2x improvement in performance in most cases. Part of the reason for this improvement is that Spark will be more efficient at the file I/O than MapReduce is. Additionally, when you use multiple job steps chained together, some of them may output a smaller amount of data that Spark can pass to the next job step in memory and avoid that same I/O overhead. Finally, a simple operation, regardless of whether the data fits into memory or not, is going to be about a 2x improvement as well, and this really refers to the simple operations that are completed in one scan of the data. A factor that really helps Spark excel is when an operation needs to iterate over data. That's where the best performance gains are going to be because they can do these operations while holding the data in memory.